Good afternoon, everyone, and thank you so much for joining us. We are going to take just a couple of minutes here on the front end to let folks log in and let the technology catch up. So as folks continue to log on to the program, just know that we are taking the first couple of minutes here and letting folks catch up and get logged on. We appreciate everyone's willingness to spend an hour with us on this beautiful Wednesday afternoon. Just a couple of general housekeeping tips. When you join the webinar, you will be muted and your camera is also turned off. We invite you to ask questions and to engage with Nick and the content that he's providing. Please use the chat and the Q&A functions that are located at the bottom of your Zoom menu. I will be monitoring the chat, so at the end of Nick's program, I will make sure that he receives all of the questions that you have been asking. These programs are a series of webinars created out of our relaunch task force. The Chamber has been a proud driving force of the relaunch task force, and a lot of this information can be found on our website, including our relaunch guide, which provides sector by sector instructions or guidelines for reopening the business. That can be found at lansingchamber.org. Today's program is focused on indoor air quality. COVID has changed a lot of things and made a lot of things really important as we look at reopening our economy, and air quality is one of those. We are pleased to have with us today Nick Parakis from IPLEUNE Service Company. Nick is a service account manager over there, and he has a fantastic presentation that he is going to walk you through, talking about the things that you need to pay attention to when you look at your indoor air quality. Nick, I'm going to ask you to please share your screen and pin your video, and I will turn off here.
How's that looking? Everything good there?
Nick, that looks great.
Okay, wonderful. All right, well, first off, thank you to the Lansing Region Chamber of Commerce for having me here to discuss indoor air quality. Obviously, given the current climate, anything regarding keeping the workplace safe and getting back to work is very important right now, and air quality is a huge portion of that. A little bit about IPLEUNE Service Company. So we are a full service mechanical contractor. We've been in business for over 46 years. We have offices in Grand Rapids and Lansing, so we cover those two areas and the surrounding areas as well. We're 100% employee owned, and we focus mainly in the commercial field. Pretty much anything besides restaurants we'll be out there working on. So that's a little bit about IPLEUNE. This stuff can get pretty high level pretty quick, so I try to make this presentation as high level as possible to make sure we're not getting caught in the weeds with this. So yeah, so hopefully you learn some stuff on indoor air quality, and I give you some information on things you can do to improve. All right. So to start off, I figured we'd get into just kind of some definitions. Air conditioning, obviously, it is defined as the process of controlling temperature, humidity, and motion of air in an enclosed space. The main goal is for us to be comfortable in our homes, in our workplaces, in our buildings. Indoor air quality refers to the quality of the air within the building as it relates to health and the comfort of the occupants in your building. So what is in the air? The EPA states that the indoor air can be 5 times more polluted than outside air. So generally your air makeup is about 35% of particulates, so your dust, your dirt, smoke, liquid droplets from when you sneeze or cough or just talking in general. 34% bacteria and viruses, that's your mold and your germs, things that will make us sick. And then the last bit is 31% of the VOCs, your volatile organic compounds, and that's stuff that comes from like cleaning products, fumes, gases, etc. Poor air quality can have negative effects on the occupants, obviously causing irritation to eyes, your nose, and your throat, can cause headaches, dizziness, and fatigue. And it exposes us to bacteria and viruses that can ultimately make us sick. So the last thing you want to do is come to work with some people that maybe have a cold or the flu, and then you end up getting it because your HVAC equipment isn't working properly. So what are the guidelines? Also, most of the information in this presentation came from either the ASHRA, which is the American Society of Heating, Refrigerating, and Air Conditioning Engineers, the CDC, or the EPA. So I want to put that out there just so you know where most of this information is coming from. So the ASHRA guidelines for temperature, which this obviously varies by geographic location and personal preference. But temperature, so during the summertime, 75 to 80 degrees Fahrenheit. I don't know about you all, but I keep my home generally around 72, 73. That's just more comfortable for me. But going cooler than those numbers obviously puts in more of a load on your equipment. And then in the winter months, 68.5 to 75 degrees is considered comfortable, or the right range. Humidity, the target range is between 40 to 60% relative humidity. ASHRA recommends being below 60%. Staying in that 40 to 60% relative humidity range will minimize the risk of mold growth, and it also maintains your mucosal barriers in humans, so to help prevent you inhaling and getting sick. Air purity, as we just discussed, presence of particulates, gases, viruses, bacteria, which can have negative effect on your air quality. This is addressed by having the proper levels of airflow and then ventilation and filtration, which we will discuss later on in the presentation. So those are some of the guidelines. So what affects your indoor air quality in relation to your HVAC equipment? So first and foremost is your HVAC equipment and design. And what I mean by that is, was your space that you're working in, was it designed correctly, and do you have the right units to handle the capacity needed to cool and heat and move the air throughout that building? Offices and schools versus like a machining place, production, manufacturing are completely different and would require different loads from their heating and cooling equipment. Has the intended cooling heating space changed since the original design? So a lot of times, you start your business and you're in the office, and then you're growing, and so you add more cubicles, which adds more people, which changes the occupancy, which will then change the load required on your HVAC equipment. And if that's not addressed when you make these changes, that can have a negative effect on your equipment, which will adversely affect your air quality. And is the equipment being used correctly? So do you have control of your equipment and when the fan's running? Sometimes we'll see there's hot and cold spots, and so someone may go, they're cold today, so they close their vent and then forget about it. Now that will negatively affect your airflow in your system. The next thing is the age of your equipment. How old is it? Is it old? Is it outdated? With age, maybe it's not working at its highest capacity. It might be running at 50 to 75% capacity instead of 100. And has the equipment been properly maintained? So I like to think of that as like your car, right? You get your routine oil changes, tire rotations, keeping the right amount of air pressure in your tires will affect your, the miles you're getting on your car. So the same thing with your HVAC equipment. Are you maintaining your equipment? Ventilation and air velocity. So is there the proper amount of ventilation, outside air coming in for the intended space? And I have on a later slide kind of the guidelines depending on what type of office or what type of work is being performed. Kind of talking before, is the airflow blocked anywhere? Is there a blockage in your ducts? Have your ducts never been cleaned out? Are they closed? There's dampers throughout your ducts that you may not even know. A tech or someone may have been working on them and they close them off or close it 50% to limit airflow. Who knows? Could be a number of things. Along with that, is the correct amount of air flowing through the ducts at the right speed? There are standards as far as how much air needs to be pumped through the ducts and at how fast. So, and then is the right amount of exhaust present? So is your building exhausting the air? and those contaminants. You know, I have an account that does heavy steel machining and fabrication and welding, and so the exhaust fumes that are coming up in the air from their equipment, we're having to change filters at that place monthly versus quarterly or biannually just because of the nature of the business. So all of those things will have an effect on your air quality. Filtration, as I just kind of started talking about, what type of filters are being used? Are we going cheap and just using standard filters, or do you have pleated filters? You can go HEPA and washable reusable filters as well, which we will hit later on in the presentation. And then how often are those filters being cleaned or changed? I can't tell you how many times I get called out to a site and we get on the roof and we open up the unit and there's either no filters or the filters are 2 years old. So, you know, same thing. One thing I wanted to say to the beginning is a lot of what I'm speaking about can be applied to your home as well, or residential, especially because some of our office buildings actually use residential equipment. So sorry, I went to say at the beginning. Back at it, controls. So do you have complete control over your HVAC system? How is your control system outdated? There's a handful of accounts that we work with that can only control their temperature, you know, plus or minus 5 degrees just because their controls are outdated. It's expensive to keep your control systems updated, and sometimes that gets thrown out the window. So do you have enough sensors throughout your business, throughout your office? And are they placed in the right positions or right locations to give you accurate reads on the temperature or humidity in your building? Programmable thermostats are great because a lot of times you can access them from your phone or your computer, and that gives you real-time updates as far as how your system is working. So when we talk about indoor air quality and ways that you can improve it, so first and foremost is having a HVAC preventive maintenance program. Is your equipment getting the adequate service it needs to work at its highest level? Improving or increasing ventilation if needed. Same thing with improving and increasing filtration. The other thing that's really popular is this UVGI light equipment that you can add to your current HVAC units, and that's ultraviolet, germicidal, irradiation, which we'll discuss that further. And then also electronic air cleaners, bipolar ionization equipment that you can add on. So those are some of the most common ways to improve your indoor air quality. So we'll first hit off on preventive maintenance. So as I mentioned earlier, talking about, you know, taking care of your car and routine oil change, preventive maintenance on HVAC equipment is probably one of the most important things you can do to, one, make sure your equipment is working as it should, but two, maintain the life of it and extend the life of your equipment. So we recommend having a qualified licensed HVAC technician come out and service your equipment either biannually or quarterly to keep your units performing at their highest level. So most manufacturers of the equipment will say you should change your filters quarterly. Same thing with your home. Depending on the space being cooled or heated and the type of business, you can get away with biannual, but we always recommend at least quarterly services. So maybe a spring startup of your cooling equipment with then a summer filter change and maintenance visit, and then a fall startup of your heating equipment with that winter filter change and another maintenance visit. So as I stated before, the frequency definitely depends on the type of business. So having a good preventive maintenance program will ensure your units are operating as intended and will also provide the proper airflow ventilation to your occupants. A lot of times when we're out there doing these visits, we can find out, is the fan operating at its highest capacity? Are we getting the adequate airflow? What's stopping it, for example? It also maintains the cleanliness of the unit. We clean the coils where your airflow passes over, filters, just the unit in general. We keep that super clean. The nice thing about preventive maintenance program is a lot of times you can catch the problems before they occur, which puts more money back in your pocket because it's saving some money and having less service calls. Regular filter changes and replacement of the fan motor belts also keep the equipment working as intended for a lot longer, extending that life. And then, like I said, just having that preventive maintenance program will extend the life of your equipment and improve the operating efficiency, which in turn can give you savings by having equipment operating well. So just to get an idea of how ventilation and airflow works, kind of the next step in indoor air quality. So these are just pictures of a basic typical rooftop unit that you'd have on your business. You can see the yellow, that's the outside air coming in, going through the dampers in the unit, passing through your filter, and then this is your cooling or your heating coil, which then goes into the fan and gets sent out to the rest of your building. The next unit, this shows the same thing, air coming in from the outside, but then it's also got a return then here for the air that's circulating in your building to come back through and go through the filter again. And we'll discuss the importance of that and making sure that we have enough outdoor air and indoor air to improve the air quality. So that's kind of basically how the system works. So when it comes to ventilation and airflow, there's studies that have shown that virus transmission was highest in the offices with little to no ventilation. A lot of that information came over from when the coronavirus outbreak started over in China. Another study showed that improving ventilation in US high schools was as effective in preventing the flu as if 60% of the students received the flu vaccination. So that just goes to show making sure your indoor air quality is good can really have a big impact on keeping your occupants safe and healthy. Why is ventilation needed? So when we cough and sneeze, obviously a significant volume of water droplets go out into the air. The heavier droplets can move 6 to 7 feet from the source. Drops that are under 10 microns in size become aerosolized and stay up in the air. And if you have improper airflow or ventilation, that can then be spread out to other people in the room. So make sure I'm at the right spot. All right. Yes. So proper ventilation and filtration will obviously help remove those aerosolized droplets from the air, whether it be pushing them outdoor through an exhaust or going back to the system and being caught in the filter. So how much ventilation is needed? And these are based off of ASHRAE recommendations. And just for simple math and kind of simple explanation here, we're going to do this based on a 10,000 cubic foot restaurant. So this chart on the right basically it shows from ASHRAE how much outdoor air needs to change. Sorry, let me start over. The amount of cycled air that must come from the outside via your equipment's dampers. This chart on the right side is your total indoor air change. So basically the entire air, all the amount of air in your cooling or heating space, how often it needs to change per hour. So the easiest way to explain this is basically you have a 10,000 cubic foot restaurant. So if we look over on the right side, restaurants is 8 to 12 total indoor air changes. So we'll say 10 just for simple math, and that's kind of the midpoint. So that means in an hour, your AC unit needs to pump out 100,000 cubic feet of air through that space. When you look over on this table, on the restaurants, it says the outdoor air needs to change 4.2 times. So of that 100,000 cubic feet of air, 42,000 cubic feet of that must be outdoor air. That means your unit has to recycle 58,000 cubic feet of air back into the system, and then your HVAC unit will need to pull in 42,000 cubic feet of air. So hopefully that makes sense. That's kind of the easiest way to explain it, just basically the ratio of outside air versus recirculated, reconditioned, return air through your system. So what are ways to improve ventilation? So fan performance in your HVAC unit may need to be addressed to improve ventilation. A qualified HVAC tech can help with determining your fan performance and if there's any improvement available. Is the fan, can the RPMs be increased? Is it operating at full capacity? How often is the fan coming on? So adding outdoor air to help with ventilation can also have a positive effect. So that can be something as simple as just opening the dampers on your HVAC equipment. You saw in the picture before those dampers on the unit. Like I said, we'll go out to places of business to look at their equipment, and we'll see that the dampers are completely closed, or they're wide open and they're bringing in too much air. So that's also a concern. Besides just the dampers, there's also alternate equipment that can be added to your existing HVAC system or just added to the building itself. And so there's these units are called ERV units, energy recovery ventilators. That can be a whole standalone system by itself, or it can also be installed in your ductwork. They work really well. It's basically, they help push the airflow through the ducts, and it's an added level of filtration as well. The other thing would be a DOAS, we call it a DOAS system, which is a dedicated outdoor air system. Granted, these two can become costly when you're talking about any equipment because the equipment itself is expensive and then also the labor required to install it. The other thing to improve ventilation is make sure there's nothing blocking or obstructing airflow. We mentioned, I talked before about having closed vents or maybe blocked ducts, your ducts in there have been cleaned, or your filters are plugged. So that all has an effect on the ventilation and airflow in your building. So the next and probably one of the most important things and most cost effective in terms of price is improving or increasing your filtration. So along with improved ventilation, effective filtration is very important. The effectiveness of your filters is based on a MERV rating. I'm sure you've probably heard, MERV 8, MERV 10. And basically what that is, it's a minimum efficiency reporting value, and it's a score. I have a great slide that'll give you a chart that shows how much that filter will stop based on the MERV rating. So you have your standard fiberglass filters, which a lot of you probably have in your homes. These are, your 20 by 25 by 2 inch, and they're just throwaway. They're MERV 1.4. Basically, they'll stop anything smaller than 10 particles or 10 microns, basically. Some units will have a washable and reusable filters. These are nice because they'll last longer than disposable filters, but it requires labor to clean them, and then they can harbor germs if they're not fully dry when you put them back on. They also stop, microns smaller than 10 or greater than 10, excuse me. So what we recommend and what I always tell my clients and accounts is that, we want to do pleated filters. You've seen these in the stores, I'm sure, if you're buying filters for your own furnace. They're similar to fiberglass, but they have a higher resistance to airflow and dust stopping ability. They're less expensive than the next step up, which would be HEPA, and less restrictive in regards to airflow, which we'll discuss that in the next slide. 30% pleated MERV 8 are generally what's recommended on a commercial standpoint, just because of their effectiveness at catching particulates and that stuff. So next is bag and box filters. These tend to go to, pleated filters are generally, the MERV rating is 5 to 16, it's a range from stopping anywhere from 3 to 10 size microns, 1 to 3 size microns, or even 0.3 to 1 micron, which we'll discuss kind of the significance of that at a later slide. If you want to go to the next level up, it's your bag and box filters. And these ones will get the 1 to 3 microns or 0.3 to 1 microns. They're very similar to pleated, but just much deeper, and they have a higher resistance to airflow. The negative of that is not all the equipment can fit these because of the size of them. And then the best filter you can get is your HEPA filter, which is a MERV score of 17 to 20, which is stopping particulate that's smaller than 0.3 microns. These filters pass air on a very fine scale. They trap 99.97% of particles that are 0.3 microns in size. And like I said, not all, just like your bag and box filters, not all your equipment can handle these filters. So this slide here, this is our filter chart, just so you can get an idea of what they look like. You have your flat panel fiberglass. These are your pleated ones. These two are what you would probably have in your furnace at home. Here's what a HEPA filter looks like. This is your washable, reusable filters, and that's kind of so you can see the box filter, which is, you can see why it probably wouldn't fit in most units if they weren't designed to have them. This is the MERV rating chart. So basically, I'll jump ahead a little bit because I know a lot of you are concerned about air quality and COVID. What we found out is that COVID, or what they're saying is the coronavirus is 0.125 microns when it's by itself, which means I don't think there's a filter out there that will stop that. However, when a person coughs, sneezes, or is talking, and let's say they have coronavirus, when it's aerosolized, they're saying it's anywhere from 3 to 5 microns in size when it's in the air, which then you can see that a MERV 8 could possibly stop that. Definitely your 9 through 12 will stop that. But your MERV 13, I think, is what's recommended right now by the CDC and ASHRA. And you can get your pleated filters at that rating. So some things to consider when upgrading your filters. Increasing filter efficiency may have a negative result in airflow, which will disrupt your current ventilation levels. Obviously, the better the filter is, less air can go through, which means less air is getting to your occupied space. Along with that, the stronger the filter, the more restrictive airflow, which will require more air to pass through. This will place an increased load on your fan and on your unit. Depending on what type of unit and the tonnage, it may not be able to handle that increased MERV rating on the filter side. Restricting or limiting airflow can have a negative effect on static pressure. When there's increased static pressure, your unit has to work harder. The blower motor can fail, and by working harder, it can increase your energy costs. So upgrading filters may also require more frequent filter changes, since the filters are catching more and can become plugged up faster. Especially think about right now, the cottonwood's flying. So if you increase your filters right now, you probably need to change it, every 2 months versus every 3 months. It's best to consult with a qualified HVAC tech to discuss your options when you're increasing filtration and making sure your units can handle that. The next thing besides increasing ventilation and filtration, this is pretty big, and this is what I'm seeing. I'm getting a lot of questions from my accounts, and a lot of people are opting to use this, and it's your UVGI. So it's ultraviolet germicidal irradiation. There's been a lot of research through ASHRA on this and the application of UVGI light. Basically how it works, there's 2 main applications. You have an upper room UVC system. So it uses UVC light, basically to kill the germs and kill the contaminants in the air. So I'm sure you've all seen it when you walk through hospitals or some restaurants, even office buildings, but there's the upper room UVC system, and I'll have pictures on another slide, which these are installed in communal spaces, corridors, break areas, pretty much anywhere, or near air vents. The nice thing about this is they operate 24 hours a day, and they're typically mounted 7 feet above the floor, and so they're catching the air that's circulating in their room. The other option is in the air handler UVC, which is basically in your HVAC equipment. And generally they're installed downstream of the cooling and heating coils, which I showed you in that picture. That way the air will flow through as it gets cooled and heated over the coils and then hits that UV light. So basically what happens is air from the room or the HVAC unit passes over the UVC light before being expelled out of the unit and circulated throughout your building. The UVC light will penetrate the cell walls of the microorganisms. This sterilizes them and also prevents reproduction. And you'll see there's a pretty good, I don't know if you want to say kill percentage or destruction percentage, but bacteria 98.85%, viruses 99.03%, and then molds at 78.8%. So the UVC light is always on, which allows us to also disinfect the surfaces of the HVAC unit when the air is not flowing through. Like I said, the best place to put these is near your heating coils. And by having that UVC light on the coils, it allows the coils to stay cleaner. Sometimes, mold likes to grow in damp and dark, cool places. the coils inside your HVAC unit is a perfect spot for mold to grow. So the added bonus, most of these units come with an activated carbon filter, which will reduce odors, fumes, pollutants, the VOCs, mold, mildew, all that stuff. So some things to consider when upgrading to a UVGI system. They are more expensive than upgrading filters up front. However, it's a one-time upfront cost, including labor, and besides your bulb replacement, which you only do that every 2 years. So yes, it's a little bit more expensive than your filters, but it's that one-time upfront cost, and the lights generally last 2 years, and they don't really lose their efficiency or their power as far as the power of eliminating the contaminants throughout that time. They do a great job at killing the contaminants, but they do not trap any of the particulates like a filter does. So whatever survives and makes it past the UV light will then get recirculated into the air. So that's just some things to consider when comparing UV light versus upgrading your filters. So, excuse me. This next slide here basically just shows an illustration of how that UVGI equipment works. This would be like an application in your current rooftop unit. And so warm air comes in through the dampers, goes through the filter. Whatever the filter doesn't catch then goes over the coils to be heated or cooled, and that's when the light hits it before going out. I mentioned the upper room ones. This is a picture of what that may look like as you see these people have it installed below the vent. So I'm guessing they're hoping to catch it as it comes out. Now, there's a lot of good research and that shows the UV light works very well. And it's a great option when trying to improve your indoor air quality. All right. So the next option you have is an electronic air cleaner or ionization unit. So what these are, these electronic air cleaners are pieces of equipment very similar to the UVGI lights in that they can be retrofitted to your current equipment. And they use positive and negative oxygen ions to seek out contaminated air particulates and destroy them. So the difference there is when the UVC light hits the air, it kills everything or almost everything right there. These send out, basically they charge the air ions and they go out kind of seeking the contaminants in the air. How does it work? The airflow passes through the electronic air cleaner, which energizes that air to form positive and negative air ions. The airflow then distributes these energized ions into your space by the duct system, or they also are standalone, just like that upper air one, the UVGI. The energized ions will seek out and neutralize contaminated air particulates in a given space. So with these electronic air cleaners and ionization, they work well. They're more expensive than a UVGI system. However, a lot of the results that studies have shown have shown positive results in a lab setting. But as far as the results in the field, they're still kind of up for debate, the efficacy of this option. So you have some options there. So indoor air quality as it relates to COVID-19, and I kind of spoke on this before. So COVID-19 by itself is very small, about 0.125 microns. However, when it's aerosolized after coming from a cough or a sneeze, it's said to be 3.5 microns, which we know, well, studies are showing, and these are changing by the week, it seems like, but we believe right now the virus can remain in the air for up to 3 hours. Because of the size, when aerosolized, in theory, it can be trapped by filters with a MERV 13 or greater score. So I came across, when kind of preparing for this, I came across an incident that happened early on, actually over in China. And at first, the article was kind of blaming the HVAC filtration system. But basically what happened is there was a family at a restaurant, and it's believed that there was an asymptomatic person there that somehow spread coronavirus to 3 different families that were also eating at this restaurant. They all were practicing social distancing. The tables were spread apart. But what they found was it wasn't so much that the AC unit didn't trap or catch the coronavirus, but this goes back to kind of the design aspect of your HVAC system. What happened, because they swabbed the HVAC system and there was no coronavirus present there, what they're saying happened is the airflow was not designed correctly in this restaurant. This person must have coughed or sneezed or something, but the infected coronavirus particulate was in the air. The airflow pushed it on to basically spread it throughout the restaurant. And it ended up infecting 3 other families, which just chain reaction from there. So it's really important that not only are you looking at filtration and ventilation and whether you decide, UV light might be right for you or these bipolar ionization, but you also need to have a qualified tech come in and make sure that the airflow and your equipment is designed correctly for your space. What we've kind of learned throughout all this is that if your building already has good airflow and ventilation, as well as humidity control, which is important, a combination of possibly increasing your filter resistance and UV light is probably the best bet at preventing the spread of coronavirus through your system. It's probably your most cost-effective way as well. We've learned that transmission through the HVAC system is not a huge concern as much as it is to being close, which is why we're practicing social distancing. But that restaurant example, it does show you a possibility of how it could spread. So that kind of wraps up. So when discussing workplace safety for your occupants, air quality needs to be one of your top priorities. Studies have shown that quality and comfort in the school and workplace will also have a direct connection to increased productivity. So there is a study that showed in Southwest US showed students' test scores improved when the ventilation was increased in classrooms. So that can be directly applied to productivity. So not only is air quality important, but also the comfort of your occupants and providing a good, safe work environment will have a positive effect on the output of your employees. Ventilation and proper filtration is key to controlling and improving your indoor air quality. There are options to add additional equipment to your current HVAC system to help improve your indoor air quality. These can become pricey when you consider the cost of the unit and the labor to install them, but they are out there. And the most cost-effective approach, obviously, is ventilation and filtration, possibly with that UVC light technology. But when it's all said and done, if your equipment isn't being maintained, that's the first step, is making sure your equipment is maintained and working properly. HVAC preventive maintenance is vital to the HVAC system, extending the life of it and providing long-term clean, comfortable air to your occupants. So that's all I have for everybody. I hope I didn't go too fast. I will make sure that this presentation is available for you all. But yeah, so that's my 2 cents on improving indoor air quality in the workplace. So I guess we can open up to questions now.
Great. Thank you so much, Nick, for all of the information. Obviously, this is a topic where, like you said earlier, you can get very technical and very in the weeds with some of the science here. We did have a specific question come in, and it's a little bit long, so I'm going to read it to you like in a couple of parts. We went with electronic ionization over the light, strictly from a maintenance standpoint, no changing lights, etc. Is that a good choice? Also have heard the EPA wants 30% outside air minimum. Is that true? And what is that going to do with energy costs, 90 degrees, high humidity here in Michigan?
Right. That's a great question. When it comes to the ionization over the light, it's really personal preference. The studies I've seen have shown that also, I guess, to start off with that question is what's the business that, or what's the air there? What type of business is happening there? Like, is it manufacturing? Is it warehouse? So, but besides, it's a school. Okay. So yeah, so I can't say that it's one's better than the other, except what we've seen studies wise, the light has shown more favorable studies. The ionization works. And like you said, to your point, you won't have to change out lights. So yeah, both are viable options. It totally comes down to personal preference and budget. As far as the EPA, I have not seen that 30%, but like I said, things are changing very quickly, and codes and law and all that are changing. So that's something I'll look into. Maybe someone kind of upper management in our company can help me out with that. But I have not seen that they're requiring 30% outside air. Because you're right. Yes, if you're bringing in that much outside air, your cost will definitely increase trying to condition that. Hopefully that answers your question. Like I said, when it comes to ionization versus the light, it's really personal preference. And I think you're fine with that, especially if you can handle the budget there. So.
Yeah, great. And I do want to remind everybody to submit questions via the chat or the Q&A function as we kind of get into the Q&A portion of our event. How can you determine your air quality or your ventilation in your business? How do you set some benchmarks for you to know that you're improving against?
Yes, great question. And I knew that one was coming. So there are kits, and I just did a quick Amazon search. There are kits that you can buy, and I can't speak personally to how well those work. What I would recommend is getting in contact with a qualified, licensed HVAC company where they can come out. One, I mean, anyone who's bought a home knows there's radon testing. They can take air samples and give you an accurate read of how the quality of your air. So I would recommend doing that. As far as checking on ventilation rates and airflow, your tech, an HVAC tech, has the tools when they're out there providing service to your equipment to test all of that and give you a reading. There's crazy math equations that will let you know based on the size and occupancy of where those parameters should be. But yeah, so that the best bet would be to have someone come out and do kind of like a trial or service inspection.
There was a question about kind of new buildings versus old buildings as you kind of look at the heating and cooling concerns. If someone is in an older building, what should they, look at or be concerned about versus somebody who's potentially in maybe a newer build? What are some differences there?
So the newer builds, because of the restrictions and code changes, like they're built so tight, it actually kind of had a negative effect when it came to HVAC because the pressure, keep maintaining your static pressure. So when it comes to new and old buildings, the new buildings, obviously the chemicals and the equipment and materials are a lot different. So there's not as a huge concern there. The older buildings, you probably want to look out for, lead-based paint. Is there asbestos in the building? When it comes to ventilation and airflow, are there leaks, windows, how are the windows, is air getting out or coming in? That all can have an effect on your HVAC system and keeping the proper balance, that pressure, which can either make your HVAC equipment work harder or basically work against itself. Those are kind of the things I would focus when it comes to new versus old. Great,
that's really helpful. This is a little off topic, but it was mentioned, with the kind of global shutdown since kind of the March timeframe. There's been a really positive impact on, air pollution, in general. We've seen a real decrease in that. How does that factor in, to improved indoor air quality as well?
Yeah, I guess I can't really talk on how it has impacted, just because I haven't, there's nothing really in front of me. But what I would say is the fact that we are putting an emphasis on this, your indoor air quality, just because the outdoor air coming in is gonna be cleaner, that means your indoor air is not going to be as bad. And with people really taking social distancing, and we spoke earlier, you know, we're basically being cleaner because of this pandemic, which we should have been from the get-go. But just everything we come in contact to is going to be that next level of sterile or cleaner, I guess you could say. Yeah.
That kind of, you know, circles back to you know, the impact on COVID, and how can a business, quote unquote, use their indoor air quality as a consumer confidence piece, or you know, a staff confidence piece.
Right. Yeah, I mean, we discussed, like you mentioned, the hotel, and the people are calling in now asking, what are your cleaning products? What are they using? How often are you sterilizing? So being able to say, hey, we've increased from our standard MERV 4 filters to MERV 13, which is recommended by the CDC to help with our air quality. We're bringing this much more outside air in. We've added light, you know, the UVC light to help kill contaminants in the air. I mean, that's all, that'll go so far with making people feel safe and comfortable, especially like if you're thinking the restaurant, like, because yes, outdoor patios are opening up and we're at 50% capacity, I believe, for indoor. But being able to say, hey, these are what we are implementing. This is what we are doing to make sure you're safe will go a long way, I would imagine.
Perfect. Well, that was all the questions that I had received from the audience. If there's anything else that somebody wants to submit really quick, go ahead. But Nick, you know, if you have any kind of final thoughts, or would like to just kind of wrap it up on behalf of IPLEUNE, that would be great.
Yeah, so my final thoughts, one thing that I wanted to hit on is, obviously right now, places have been shut down. So if you are deciding that maybe UVGI light or an ionization kit might be something you want to do, demand is huge. I have a lot of my accounts that wanted to upgrade their filters to a higher MERV rating, and most of them have been on a 2 or 3 week lead time to get those filters in. So with that said, if that's something you're considering at your business, I definitely would do that sooner versus later, just because the demand is only going to continue to increase, especially as cases are spiking in other parts of the country and the world. So, but really, thank you for having me. I really hope this was beneficial for you all. And I can't stress, obviously I'm a little biased because I worked in the service department, but preventive maintenance, it will go such a long way with your air quality and the performance of your HVAC system. A lot of people see that as an added cost, but really it tends to be a cost saving versus just calling when something breaks. Preventive maintenance will go a long way along with all those other things that I spoke about. So like I said, thank you for having me, and hopefully this was beneficial for you all.
Wonderful. Thank you so much, Nick, for sharing, and for IPLEUNE for allowing you to join and share all this content. That was wonderful. Thank you for your final thoughts. It's a great reminder that you really can't put a price on the health and safety of your staff and of your customers. So with that being said, I wish everybody a wonderful Wednesday. I'm proud to give you back 11 minutes of your 1 o'clock hour here. But Nick, thank you again. We will be sending out a follow-up email with the content that Nick shared and his contact information. So should you have any direct questions, please feel free to reach out to either Nick or the Chamber, and we'd be happy to help.
Definitely. Thank you.
Other than that, thank you guys. Thank you for joining us. Have a wonderful day.